Hello guys, welcome to our channel. So today we are going to continue with our O-level revisions. So today we are having this question paper of November 2021 session. So this is mathematics paper 1, and I do believe guys that you have already done this paper before, so that you can make use of this session to improve yourself and to improve the way you approach certain problems, certain questions, and I hope this session will be useful to you, and you should pay attention to every data, to every concept, and to every theorem we are going to share in this video. Okay, so just make sure every time you open a question paper you read these instructions to the candidates. So this is paper 1 for ZIMSEC. So in this question paper we are not required to use calculators, and write your name and the center number and candidate number in the spaces. So we are going to answer on this question paper, and we are required to answer all questions. Okay, so the question number 1, it is saying express 30.098 correct to the nearest 10. So we are required to express 30.098 to the nearest 10. So 0 is our unit, and 0 here is our 10th, and this one 9, it is our 100th. Okay, so for us to express our answer correct to the nearest 10th, we consider this 9 here. So if this number is greater than 0, then greater than 5, we then round this 0 to 1, and if this number is less than 0, we maintain less than 5, we maintain that 0. So 9 is greater than 5, so we can simply round this 0 to 1 to say it is now 30.1. So 30.1, it is our final answer for number 1A. And let us move on to the next part of the question, which says express 30.098 to 4 significant figures. So we are also having 30.098. So this is our first significant figure, the second, the third, and the fourth. So we are considering this this number here, 8. So we are now saying is it 8 greater than 5? And if it is greater than 5, we then round this 9 to 10, and if it is less than 5, we then maintain that 9. So 8, it is greater than 5, so we can now say it is 30 point and we rounded this 9 into 10, so it is now 30.10 correct to 4 significant figures. Okay, and let us move on to the next part, the part C of the first question number 1, which is saying express 30.098 in standard form. So we are still having the same question, 30.098 in standard form. So to express number in standard form, we maintain a number, so our number must be in this range from 1 up to 9.9. okay, so for us to express 30.098, we then say it is 3.0098, and we are required to multiply this number by 10 and raise that 10 to a certain number, so that you can go back from this new value here, 3.0098 to 30.098. So we are going to raise our 10 to the nearest 1, our 10 to the power 1, because if we multiply 10 by 3.0098, we then return to this value here. So our answer in standard form, it is 3.0098 times 10. Okay, so here is our final answer. And let us move on to number 2 of our question paper, which says express 4 2 over 3 as a recurring decimal. So we are having 4 2 over 3. So this is a mixed number. So the first thing is to convert this mixed number into improper fraction. So for us to convert this mixed number into improper fraction, we multiply this 4 here by this 3, and then add the result to 2, and then divide everything by 3. So we are saying it is 4 by 3 plus 2. So let us simplify here to say 4 by 3, it gives us 12 plus 2, it is 14 divided by 3. So here is our improper fraction, but we are required to give our answer as a recurring decimal. So let us try to divide 14 by 3. So if we divide 14 by 3, it is 3 into 14. 3 into 14, it is what? 4. Remember 2 and carry 0. So 3 into 20 gives us what? 6. Remember 2. And 3 into 20 again, it is 6. And 3 into 20, it is 6. So our final answer, it is 4.6. So put a dot here to represent a recurring decimal. Okay, so here is our final answer for this part A of question number 2. And let us move on to the next part of our question, which says find the value of 10 minus 10 divided by 2 plus 2 times 2. So here we are going to use our BODMAS. So we are going to use our BODMAS, where B, it is for bracket, and here it's off. D is for division, and M is for multiplication. A is for addition, and S for subtraction. So with this idea of BODMAS, we then say we are having 10 minus 10 divided by 2 plus 2 multiplied by 2. So we are going to start by simplifying here, where we are having our division. So it is now 10 divided by 2, which is equal to 5. So it is 10 minus 5 plus 2 times 2. And what else? We are then go to multiplication. So we are going to simplify here, where we are having our multiplication. So it is now 10 minus 5 plus 2 by 2. It gives us what? 4. And what is next is addition. So we then say 10 plus 4, what is it? It gives us 4. It gives us 14 minus 5. So if we subtract 45 from 14, we then get 9. So our final answer, it is equal to 9. Okay. And let us move on to the next part of the question, number 3. In number 3, we are given this sequence of numbers. So we are having 2, 3, 5, 8, and 12, and we are required to write down the next term in the sequence. So our sequence, it is 2, 3, 5, 8, 12. So the best thing is to figure a trend within this sequence, to say from 2 to 3, what happens for us to come up with 3 from 2. So we have add 1 from 2 for 2 for us to get 3, and for us to get 5 from 3, we have add 2 to 3, so that we obtained 5. And for us to get 8, we have added 3 to 5, so that we can get 8. And for us to get 12 from 8, we've added 4 to 8. So our sequence is now, we are adding 1 here, we are adding 2 here, we are adding 3 here, and we are adding 4 here. So 2 plus 1, it gives us 3, 3 plus 2, it gives us 5, 5 plus 3, it gives us 8, 8 plus 4, it gives us 12. So we are going to add 5 here to 12. So our next term in the sequence, it is 12 plus 5, which is equal to 17. So 17 becomes our final answer for this number 3A. And let us move on to the next part, part B. We say simplify 20 minus 8 divided by 20 plus 8, giving your answer as a common fraction in its simplest form. So we are having 20 minus 8 divided by 20 plus 8. So we can simplify on the numerator by subtracting 8 from 20, which is equal to 12. And on the denominator, we can simplify by adding 8 to 20, which is equal to 28. So for us to reduce this fraction into its lowest term, we can divide both the numerator and the denominator by 4. So if we divide 12 by 4, it is equal to 3, and if we divide 28 by 4, it gives us 7. So 3 over 7 becomes our final answer for this number 3B. Okay, and let us move on to the next part, the number 4 for question paper, which says list the prime numbers between 14 and 20. So the first thing is to define what is a prime number. So a prime number, it is a number that is divisible by itself and 1. So we are required to list the prime numbers between 14 and 20. So the first thing is to write the numbers in between 14 and 20. So we are having 14, 15, 16, 17, 18, 19, and 20. So 15, it is not a prime number because it can be divided by 5 and 3, and 16, it is not a prime number because it can be divided by 2 and 8 and 4, and 17 becomes our first prime number, and 18, it is not a prime number because it can be divided by 2, 6, and 3, and 19, it is our second prime number. So 17 and 19, these are two prime numbers between 14 and 20. So we are required to write this number 801,008 in width. So it is 801,008. Okay, and let us move on to the next part, the part B, which is saying express 6.65 hours in hours and minutes. So we are having 6.65 hours, and we are going to express 6.65 hours in hours and minutes. So if we are having 6.65 hours, this simply means that this 6 here is 6 hours. So we then required to calculate how many minutes are 0.65 hours. Okay, so given that 1 hour it is equal to 60 minutes, what about 0.65 hours? It will be equal to less. So from our proportion, we can now say it is 0.65 by 60 minutes. So let us multiply 0.65 by 60, and this gives us 39 minutes. So our final answer, it is 6 hours 39 minutes. Okay, and let us move on to the number 5, which is saying list the first 3 values of x such that x is greater than or equal to 1 but less than or equal to 4, where x is a natural number. So we are required to state the values of x within this range when x is greater than or equal to 1 but less than or equal to 4. So the numbers that are in between this range, we are having 1, 2, 3, and 4. So our question requires us to list the first 3 values of x. So the first 3 values of x, it is 1, 2, and 3. So we can eliminate 4. So this is our final answer for this number 5a. So the part B, it is saying express 270 as a product of its prime factors in index form. So we are having 270. So we can start by dividing this 270 by our lowest prime factor, which is 2. So we can test if 270 can be divided by 2 without leaving a remainder. So if we divide 270 by 2, you will get 135, and 135, it is not divisible by 2, so we can try another prime factor. So 3, what about 3? So if we divide 135 by 3, you get something like 45. So it is now 45, and let us divide 45 by 3 again. This gives us what? 15. And let us divide 15 by 3. This gives us what? 5 and 5, 1, like this. So 270 as the product of its prime factors, it is equal to 2 to the power 1 times 3 to the power 3 by 5 to the power 1. So here is our final answer, expressing 270 as a product of its prime factors in index form. So the question number 7, it is saying 1 over x squared minus 1 minus 1 over 1 plus x is a single fraction in its simplest form. So we are required to express these two fractions as a single fraction in its lowest form. So we are having 1 over x squared minus 1 minus 1 over 1 plus x. So again, factorize on the denominator of the first fraction, because here we are having a difference of 2 squares. So we can say it is x minus 1 and x plus 1 minus 1 over x plus 1. Okay, so x plus 1 multiplied by x minus 1 becomes our new common denominator. So if we divide this x minus 1 multiplied by x plus 1 on this first fraction into this common denominator, we get 1, and then multiply the numerator by that result, it is 1 minus, and if we divide x plus 1 multiplied by x minus 1 by this denominator with the second fraction, we will get x minus 1, and then multiply x minus 1 by 1, and this gives us x minus 1 like this. So let us try to simplify on the numerator. So this gives us 1 minus x plus 1 over x plus 1 effect of x minus 1 like this. So if we simplify again on the numerator, we'll get 2 minus x over x plus 1 x minus 1. So here is our final answer. And 4 in base 5. So this is the largest 4-digit number in base 5. Okay. And let us move on to the next part of the question, which is saying convert triple one in base 8 to a number in base 7. So when we are having a number in another base, and then we are required to convert this number into another base, the first thing is to convert this number into base 10, and then from base 10 we can convert it into this required base. So given that we are having 1 in base 8, and for us to convert this number into base 10, then say 0, 1 and 2. So it is 8 to the power 2 by 1 plus 8 to the power 1 by 1 plus 8 to the power 0 by 1, like this. So 8 to the power 2, it is 64 plus 8 plus 1. Okay, so 64 plus 9, this gives us 73. So 73, it is in base 10, and we are required to convert 73 in base 10 into a number in base 7. Or to convert 73 in base 10 into a number in base 7, you can say it is 73, and we are having base 7 here. So we divide this 73 by 7, and it is 10, remainder 3. And if we divide 10 by 7, it is 1, remainder 3. And if we divide 1 by 7, it is 0, remainder 1. And then consider this direction like this. So our number, it is 133 in base 7. So here is our final answer for this question 8b. And let us move on to number 9. And in number 9, we are required to factorize completely, and we are having x squared, a factor of y plus 1 minus y minus 1. So we are having x squared, a factor of y plus 1 minus y minus 1. Okay, so the first step is to say x squared y plus 1, and then we can factor out minus 1. So if we factor out minus 1 here, it is now y plus 1. And as you can see here, we are now having a common factor, y plus 1. So we can factor it out to say it is now y plus 1, a factor of x squared minus 1. And we can also factorize x squared minus 1, because here we are having a difference of 2 squares. So it is now y plus 1 x minus 1 x plus 1. So here is our final answer. And let us move on to number 10. So in number 10, we are required to evaluate log 64 in base 4. So we are having log 64 in base 4. So the first thing is to equate this log into x. So if we equate this log to x, and from our laws of logarithms, we understand that if we are having log b in base a being equal to x, b, it is equal to a raised to the power x. Okay, so we can use this idea to simplify here to say it is 64 being equal to 4 raised to the power x, and we can also express 64 as 4 raised to the power 3. So 4 raised to the power 3, it is equal to 4 raised to the power x. So if our bases are equal, we then equate the powers. So it is 3 being equal to x. So x, it is equal to 3. So therefore log 64 base 4, it is equal to 3. So here is our final answer. And let us move on to the part B of our question. So in this question, we are given this log 8 over log 16, and we are required to simplify. So given that we are having log 8 over log 16, so the idea that we are going to use, it is this, if we are having log a raised to the power b, it is equal to a log it is equal to b log a. So we can simply drop this power here. So by making use of this idea to simplify this, we can now say 8 can be expressed as 2 to the power 3, and 16 can be expressed as 2 to the power 4. So log 8, it is log 2 to the power 3, and log 16, it is log 2 to the power 4. Okay, so this is equal to 3 log 2 over 4 log 2. So these log 2's can cancel, so we are going to be left with 3 over 4 So 3 over 4 becomes our final answer for this number 10. And let us move on to number 11. So in number 11, we are given these simultaneous equations. So we are having 2x plus y being equal to 4 and 5y minus 4x being equal to 13. So for us to solve such kind of simultaneous equations, it's either we use the elimination method or the substitution method. So in this case, we can simply use the substitution method, because we can simply make y the subject on this first equation. Okay, so if 2x plus y is equal to 4, therefore if we subtract 2x both sides, y will be equal to 4 minus 2x. And let us substitute this value of y back into the second equation. So it is now 5 a factor of 4 minus 2x minus 4x being equal to 13. So if we expand this bracket on the left hand side, it is 20 minus 10x minus 4x being equal to what? To 13. Okay, so it is 20 minus 10x minus 4x, it gives us minus 14x being equal to 13. So we can shift this 20 to the other side of the equation and it becomes negative. Therefore it is minus 14x being equal to 13 minus 20. So 13 minus 20, it is equal to minus 7. Therefore it is minus 14x being equal to minus 7. And let us divide both sides by 14 for us to solve this equation. So if we divide both sides by negative 14, x will be equal to minus 7 divided by minus 14. So these are negative going to cancel. So x, it is equal to 7 over 14. And if we reduce this 7 over 14 to its lowest term, it gives us half. So x is equal to half. And let us try to calculate the value of y using this equation here. So if y is equal to 4 minus 2x and x is equal to half, therefore y is equal to 4 minus 2 multiplied by half. So if we multiply 2 by half, we will get 1. Therefore y is equal to 4 minus 1 and y is equal to 3. So this is the value of y. And let us try to prove that these values of x and y can satisfy the equations, these simultaneous equations. Okay, so given that x is equal to half and y is equal to 3, let us try to prove the first equation, that it is equal to 4. So it is 2 multiplied by half plus 3. So 2 multiplied by half, it gives us 1 plus 3, which is equal to 4. Therefore these two values satisfy the first equation. And let us try to prove for the second equation. So it is 5 multiplied by 3 minus 4 multiplied by half. So 5 by 3, it gives us 15, and 4 by half, it gives us 2. So it is 15 minus 2, which is equal to 13. Therefore these two values also satisfy the second equation. So our value of x, it is equal to half, and the value of y, it is equal to 3. And let us move on to the next question, question number 12. So in question number 12, we are given this expressions 10 multiplied by x plus 1 and 8 multiplied by x plus 1 squared. So we are required to find the highest common factor. So the highest common factor, we are having 10 x plus 1 and 8 x plus 1 squared, like this. So the first thing is to express 10 as a product of its prime factors. So if we divide 10 by 2, it is 5, and 5 by 5, it gives us 1. So 10, it is equal to 2 by 5. And let us try also to express 8 as a product of its prime factors. So if we divide 8 by 2, it gives us 4. 4 by 2, it gives us 2. 2 by 2, it gives us 1. Therefore 8, it is equal to 2 raised to the power 3. So our highest common factor, what is common here, it is 2 and 2. Therefore 2 becomes our common factor, and x plus 1. So it is 2 a factor of x plus 1. This is our highest common factor. For the expressions 10 a factor of x plus 1 and 8 a factor of x plus 1 squared. And let us move on to the next part, which requires us to calculate the lowest common multiple, or the LCM of these expressions. For the LCM, the lowest common multiple, we then say it is 2 to the power 3 by 5 to the power 1. So for 2, we only consider 2 that is being raised to the highest power in these two expressions. So For 10 we're having 2 raised to the power 1, and for 8 we're having 2 raised to the power 3. So we are only taking 2 to the power 3, and so this gives us 2 to the power 3 is equal to 8 by 5. It gives us 40 multiplied by x plus 1 squared. So 40 multiplied by x plus 1 squared, it is our lowest common multiple. Okay.